Hi everybody, and thanks for tuning in to our video here on our note sheet, which is titled Equations of Horizontal and Vertical Lines. And I'm going to tell you right now, these are the weirdos. That's why I use the word weird in here. They're just different. They don't make sense at first, but then they do make sense. So go along with me here. I just have two examples for you today. We're going to make sense of this. So look at example 1. It says, let's try graphing the line y equals 3. Y equals 3? What? That doesn't look like any of the forms we've been studying. It doesn't look like slope-intercept form. Where's the mx plus b? It sure doesn't look like standard form. Doesn't look like point slope form. So I say, this is weird. Where's the x? There is no x in the equation. It's just y equals 3. So when I'm stumped on how to graph something, I always revert back to a table. So let's just kind of look here. So there's no x. So nothing here depends on x. So if I make a table here, let's just make an xy table, right? So y is going to be 3, 3, 3, 3, no matter what the x is. So maybe the x is, I don't know, -4. Or maybe the x is 0. Or maybe the x is 2. I can make x anything I want, and as I do so, that y is stuck at being 3. So let's look at what that pans out as a graph. I know how to plot ordered pairs. If I plot -4, 3, that's right here. And if I plot 0, 3, that's right there. And if I plot 2, 3, that's right there. Well, how do they line up? If I connect those dots, they line up in a horizontal fashion. So this is a horizontal line. Cool. That's why it's special. See, most of our lines have been on a diagonal, either with a positive slope or a negative slope where it drops from left to right. This is straight up horizontal. So what we can write down here is that horizontal lines, let's just make a little notes here. Horizontal lines, they have their equations. Equation will be in the form, it's got its own form, y equals, I'm going to put it as y equals c, where c is a constant. It's just a number, right? There's no x. Y equals c. Y equals a constant, just the way it was given in this example. Now, the only other thing I really want to talk about here is what's the slope? What about the slope of a horizontal line? So slope of a horizontal line would be the last thing I want to talk about. Well, now that we have a graph, we can count, rise, and run between points. So maybe we do something like m equals, we know it's going to be the rise over the run, or the change in y over x. So let's look. So if we move, I don't know, let's just pick these 2 points right here, this one and this one, okay? So to get from left to right, to get from here to there, how many do I rise? How many do I rise up or come down? You can have a negative rise too. You see how you rise nothing? Rise is 0. What about the run? 1, 2. So 0 over 2. Well, 0 divided by 2 is 0. So I would have to say the slope of a horizontal line is always going to be 0. Because think about it, if it's horizontal, you're never going to rise, but you are going to run. That puts 0 on the top, so that's really cool. Okay, now let's go down to our second and final example on this video. It says, let's try graphing the line x equals 3. I said this is weird. There's no y in the equation. These don't look like the equations we've been working with. So let's go to our good old table. So let's do an xy table. And this time, the x is always 3. 3, 3, 3. No matter what the y is. So maybe I make y -4, 0, and 2. Let's plot them. 3, -4. Okay. 1, 2, 3. 1, 2, 3, 4. 3, -4. 3, 0. And 3, 2. See the difference? Now the points are lined up in a vertical fashion. This is what we call a vertical line when it runs up and down. Okay, so what have we learned? Well, let's talk about equations. So vertical lines, the equation will be in the form, and if you look at our form here, x equals c, where c is a constant, just a number, right? Okay, x equals c. Now, let's talk about the slope. The slope of a vertical line, it's always going to be the same. That's the cool thing about vertical and horizontal lines. They're always the same no matter where they're positioned. Okay, the slope of a vertical line, here we go, m equals. Okay, let's count, rise, and run. Let's just pick these 2 points here. These 2 here, I'll darken them. So to get from bottom to top, oh, wow. The doorbell just rang and the dog is barking. Pardon me. Hold on. Go ahead. Sorry about that, guys. I'm making this video at home and the dog is barking at the door. Awesome. Okay. We were almost done too. Such is life, right? So let's count the rise and the run over the barking. So the rise from point to point is 2. But the run is 0 because I don't go to the right or the left any, do I? So this is 0. And we know that fractions whose denominator is 0 are classified as undefined. So vertical lines have an undefined slope. That's really all there is to this, guys. So you just have to kind of memorize this. And if you don't want to memorize it, that's okay too. You can always make a table. You can always make a table. Once you have the table, you have the line. Just remember, when you're making the table, if they give you the y's are consistent, and you pick anything over here. If they give you the x is consistent, and you pick anything over there. Once you plot them, you're going to see if it's horizontal or vertical. And then the slopes, you can either memorize that this one is 0 and this one is undefined, or you can just take your line, pick 2 points, and check out your rise and your run, and you'll know. So that's all there is to it. So thanks for watching.